Hello everyone, welcome to Webutorial.com. Today we will see this problem which appeared in XAT 2013. This question came from geometry. Let's read this question for a moment. The radius of a circle with center O is root 50 centimeters. A and C are 2 points on the circle. B is a point inside the circle. Length of AB is given. Length of BC is given. Angle ABC is 90 degree, and we have to find the square of distance OB. This problem becomes complicated when student starts to make the drawing in a different way. I'll show you what the problem comes from. Suppose this is our circle and this is the center. Okay, let's label it O. Then we have 2 points. Let us call A. Let us call something over here B, and then we have sorry, that point was C. Then we have another point B over here, something like this, such that this is a 90 degree. Then the lengths are given, and then people start to join a few lines more, something like this, and then they are in a bad situation because this figure looks pretty bad and it does not look very easy to solve. So the better way to draw the figure is something like this. I'll just erase this part and draw it again. So let us assume this is our circle, and I'll mark the center. Hold on. Suppose this is the center, and let us draw A, B and stuff. So suppose I'll draw the line like this, then something like this, and let us name them. So this point, as it was told, this is given as A, this is C, and this point over here is B. Okay, now there is a construction involved over here. What we will do is that we will extend AB and BC to the points on the circle itself, something like this. 1, something like this. Let us call these points X and Y. Suppose this is X and this is Y. I'll just write down the basic information over here, and then the problem is pretty simple to solve. As given in the problem, AB is 6, BX is, let us assume it is X, then BC is given as 2, let us assume BY is Y. What happens in circles is that if two chords intersects, then the product of the intercepts is same. What I mean to say is something like this, that AB BX will be same as BC BY. This tells us that 6x is same as 2y, or y is 3x. Now the problem is almost done. We will do some more construction and the problem will be finished. Just take a look. Call this O. We'll drop some perpendiculars. I'll choose a different color for that. Suppose this is our first perpendicular over here. Then we have another perpendicular over here. We should name them as well, right? So call this M, call this N, and we will calculate the values. We will draw one more line. This will be helpful for us. I'll use a different color for that also. Okay, not very different. This is different. Okay, so let us write down the values. My will be equal to how much? My will be equal to Cy by 2. So this is how much? This is 2 plus 3x by 2. Next, we will calculate the value of OM. OM will be equal to BN. As you can see that this angle and this angle as 90, this is also given as 90, so this is kind of a rectangle, ONBM. So BN can be calculated like this. BN equals to NX minus BX. So this value is how much? Nx can be written as 6 plus x by 2 minus bx is x. So this comes out to be 6 minus x by 2. Okay. Now from Pythagoras theorem in triangle OMY, use Pythagoras. So we'll get something like this. We'll get an equation like this: 2 plus 3x by 2 whole square plus 6 minus x by 2 whole square equal to 50. If you solve this, use the quadratic and all, everything cancels. In the end you will get something like this: 10x square equal to 160, which means x is how much? X is 4. Whatever is the unit, it doesn't matter for now. Okay, so now the problem is almost over. So from this we know, I'll change the color now. OM is how much? OM was 6 minus x by 2. So this comes out to be 1 centimeter. Okay, MB can be written as something like this: MB equal to CM minus CB. Okay, so CM is how much? CM is 2 plus 3x by 2 minus CB was how much? CB was 2. So calculate this value. This value comes out to be 5. Therefore OB square equal to OM square plus MB square equal to 26. So that was the solution. I hope you enjoyed this problem, and I would suggest that you remember this property always. This is very handy in circles geometry problems. Thank you. Subscribe for more videos on our YouTube channel.